Okay, so this is lesson 6-3, which is about writing word problems. And tomorrow you're going to get some practice in writing word problems, but tonight what I want to do is talk to you about different types of word problems. Because in this lesson specifically, we're going to be looking at writing problems that are either multiplication or division. So tonight's lesson will be specific to that. And I think that's really because you've spent a lot of time prior to 5th grade thinking pretty deeply about what goes into an addition or subtraction word problem. And tonight we want to really focus on kind of this family of word problems of multiplication and division. So what you're going to get tonight is 6 different types of word problems, and I'm going to give you examples of them, and we're going to solve them. And it's going to feel like a lot of writing, but I do want you to write down the word problems because I want you to be able to refer to them in later lessons. So like you can refer back to, oh, this is similar to this problem about musicians in the band, for example, to help you solve them and to help you write your own. So like I said, it's going to feel like a lot of writing, and it is a lot of writing, but it is something you will need, okay? So let's dive right in. We're doing division and multiplication problem types, and the first problem type is equal groups with the product unknown, meaning you know how many groups you have, you know how big those groups are, but you're finding the total amount. This is that basic multiplication problem that you started solving in late 2nd grade or beginning of 3rd grade. So here's an example of one. On the first day of soccer practice, 2/5 of the players were wearing new shoes. The team has 20 players, so how many players were wearing new shoes? So we know how many players, that's the how many groups, and we know the size times 2/5. What we don't know is the product, okay? So if I multiply that, I know that I can do 20 over 1 times 2 over 5. I could cross simplify right now, right? I could make this into 1 and this into 4, or I could not. I'm going to not, and then simplify later for those who prefer to do it that way. So I'm going to multiply straight across. So I'm going to get 40 over 5, which I know I can simplify by saying 5 goes into 40 8 whole times. So my answer is 8. So 8 players had new shoes. Okay, so pause now, make sure that you write down the problem and all the work, and then unpause for the next problem. The second type is equal groups, but group size unknown. This would be an example that you have the number of groups that you need, and you have the product, but what you don't have is how big each group is. So to get ready for her first semester of school, Samantha spent a total, so that's the product, of $7.92 for 8 notebooks. So what was the cost of each notebook? Well, she knows that she has 8 notebooks. She doesn't know how much they cost. I'm going to make it N for notebook. But she knows her total was $7.92. So now to solve this, I would divide. So let me make it a little bit smaller. So I know I'm going to divide. Okay, because this is one of those problems where if I use the inverse operation, I'm going to be able to find that variable. Since there's no decimal in my divisor, I'm just going to slide my decimal straight up. 8 does not fit into 7, but it does fit into 79 9 times. That would be 72 with a remainder of 7, and I bring down the 2, and just happily it's the same thing. 8 goes into 72 9 times. So I can see, I'd have a remainder of 0, that each notebook would cost 99 cents. Okay, so I knew how many groups, that's this number here, how many groups, and I knew the product, What I didn't know was the size of the groups. So let me get some of that crazy writing out of there for you. All those circles. What I want you to do is pause, copy the problem type, and the work so that we can refer back to it tomorrow. Then come on to the next one. Now, another one we might have is equal groups, number of groups, unknown. So we know how big the groups are, we know the total, but what we don't know is how many groups we're finding. So here's an example of that. How many individual pieces of cheese, each weighing 1/4 of a pound, can be cut from a block that weighs 5 pounds? So I know that I have groups, but I don't know what size they are. So I'm going to say C for cheese times 1/4 equals 5. That's my situation equation. If I want to solve it, I know I need to divide. So I would have 5 divided by 1/4 equals C for cheese. And I know that when I'm dividing fractions, first I need to make that a fraction, and then I need to keep, change, flip. So I kept the 5, changed my operation of multiplication, and flipped to the reciprocal. And that's going to equal 20/1, which equals 20 pieces of cheese. Ooh. Oh, it's being sassy. It just doesn't want that to be an E. So let's look at that. I knew that my groups had a size of 1/4 of a pound. I knew my product was 5, but what I didn't know, what was missing, was how many groups I had. And in this case, it was 20. So that's 3 types of problems right there. Now the next 3 are going to be super similar, but they have one thing in common. Instead of talking about groups, now we're talking about arrays. Okay? A theater has 39 rows of seats. Each row has 54 seats. So literally, I'm talking exactly about a rectangle. Okay? It has 39 rows with 54 in each. How many seats do I have? So that's going to be 39 times 54. I go ahead and solve that. 4 times 9 is 36. 4 times 3 is 12. Plus 3 more is 15. Now I'm working with a 50, so I put a 0 there. 5 times 9 is 45. And 5 times 3 is 15, plus 4 more is 19. I need to add those partial products. I get 6, 10, 11, and 2. So there would be 2,106 seats. So I knew rows and I knew columns, but what I didn't know was the product. Okay? Here's another one. Oopsie. This one is arrays, but your group size is unknown. So if I look at that same rectangle model, I know the groups and I know the product, but I don't know the group size. Okay, so I would know how many rows, but I don't know the size of them. Okay, so in a school gymnasium, 588 students were seated for an assembly in 21 equal rows. So 21 rows, 588 students. What number of students were seated in each row? So that's this variable. Okay, so I have 21 times x equals 588. I can solve that by doing 588 divided by 21. Goes into 58 twice. That's 42. subtract, I'm going to get 168. If I skip count 20, 40, 60, 80, 100, 20, 40, 60, that's 8. I wonder what that is. 21 times 8. Oh, perfect. So there will be 21 in each row. 21 in each row. So that's an example of how I knew my groups. I knew my whole, but I needed to find out how big my groups were. So make sure you're writing these down. Pause if you need to. All right, and the last one, again, it's an array. We know that we're going to be working with a rectangle model. Give us some more space. Whoa. Okay. The musicians are marching in a band, and they're arranged in equal rows with 8 musicians in each row. Altogether, the band has 104. How many rows are in the marching band? So we don't know this. I'll make it R for rows. So that's going to be R times 8 equals 104. Remember, to solve that, it's going to be 104 divided by 8 equals R. So if I go ahead and solve, 8 goes into 1 no times, but it goes into 10 one time. Ooh, and that gives me 24, and 8 goes into 24 3 times. So I would have 13 rows. Okay. Now I know that was a ton of writing, so I'm going to stop there. All I'm going to leave you with is an assignment. So when you're done writing all of those, and if you need to go back, do that. But when you're done, what I want you to do is choose one problem type, and you can pick any of these. Okay, you can go all the way back to, the group size and the number of groups, and you're just finding the product. Or you could challenge yourself a little bit more and maybe do one of the ones where you know the product and not the group size, or the product and not the number of groups. Okay, so you're going to choose one problem type and write a problem. Okay. Make sure it's a problem you can solve without any type of remainder. Okay, and I will see you tomorrow. Have a lovely evening. Spend time with your family.